Hello guys, welcome back to my YouTube channel. Today we have this very interesting looking question for us to dissect, okay? And actually I'm going to be using two methods for this. So the first method is going to be the longer version, or let me call it the longer method. And then the second one is going to be the short form, okay? So I'm going to attempt both methods and then you decide which one of the methods best suits you, okay? It's actually an Olympiad preparatory question, okay? So I want you to come along with me and then see how we do justice to this question. So let's get started, okay? So first is I have my solution to put down. Solution, okay? So now let's start with the first equation. We have 4 to the power of n minus 4 to the power of n equal to 48. So what I'm going to do is to rewrite these two terms in base 2, so that I have 2 to the power of 2 all to the power of n minus 2 to the power of 2 all to the power of n equal to 48. So I'm going to apply a law here. A rule in indices that if I have a to the power of m all to the power of n, it is the same thing as a to the power of n all to the power of m. It is just a matter of switching places between the m and the n. Okay. So if I switch m for 2 and 2 for m, this becomes 2 raised to power m all squared minus 2 raised to power n all squared equal to 48. So I can take this as equation 1. Then I move over to 2 to the power of m plus n equal to 32. So what I'm going to do is to rewrite this by applying this law that a to the power of m plus n is going to give me a to the power of n multiplied by a to the power of n. Okay, so I simply apply this law here to the left hand side, and so this becomes 2 to the power of m multiplied by 2 to the power of n equal to 32. So I'm going to call this equation 2. So now let's go back to the two equations. Let's look at the two equations critically. So we are going to find out that we are going to notice that we will notice that 2 to the power of m and 2 to the power of n are common to both equations, okay? You can see 2 to the power of m here, and then we have 2 to the power of n. So both are common. I mean 2 to the power of m and n are common. Equations 1 and 2. So now that that is established, we can say let P represent 2 to the power of m and Q represents 2 to the power of n. So if that's the case, we will notice that both equation 1 and 2 will become, for equation 1, we have P squared minus Q squared equal to 48. I call this equation 3. Okay? Then for equation 2, it becomes P dot Q equals to 32. I call this equation 4. Now let's go back to equation 3. We have PQ minus Q squared equal to 48. This is actually a difference of two squares, which I can write as P plus Q multiplied by P minus Q equal to 48. So I'm going to do something here. I'm going to take the square of both sides. So I have P plus Q times P minus Q all squared will be equal to 48 all squared. Now, having taken the square, I will come back here and expand. So I'm going to distribute this square over these two terms. So what I'm going to have is that I'm going to have have this expression become p plus q all squared times p minus q all squared equal to 48 squared. Now, of course, on expansion of this, I'm going to get, if I expand this, I will get p squared plus 2pq plus q squared. Okay? And then, the same way, if I expand this, I'm going to get p squared minus 2pq plus q squared equal to 48 squared. Okay? So what I'm going to do now is that if you look at this, I can regroup this and this so that what I'm going to be having will be, so this becomes p squared plus q squared plus 2pq, and then of course this now becomes p squared plus q squared minus 2pq. So this is going to be looking like this is looking more like a difference of two squares. But what I'm going to do is that to turn this into a difference of two squares, I'm going to just say that this p plus q should represent m, and then 2pq should represent n, or probably I will use a different letter. Since we already have m and n here, let me try using a different letter. This time I will use a and b. The same thing will apply to this. This will be a, and then this will be b. So if this is the case, now if we agree with this, so that means that this expression becomes a plus b times a minus b equal to 48. Don't forget that a will be p plus q, p squared plus q squared, and b will be 2pq. Now, since this is difference of two squares, so I can go ahead and transform this into a squared minus b squared equal to 48. And of course, the value of a is p squared plus q squared. So this becomes, the a becomes p squared plus q squared all squared minus b is now 2pq. That will be 2pq all squared equal to 48 squared squared squared. Okay, so from what we've done now, we can just go ahead and simplify this. From the equation, we can see that p dot q is 32. That's equation 4. If you look at equation 4, p dot q is 32. That's pq. So I'm going to replace, so this now becomes p squared plus q squared all squared minus 2.32 squared equal to 48 squared. And then I'm going to move over to this point here. So from here I have, this is 64. So I have p squared plus q squared all squared minus 64 squared equal to 48 squared. So I'm going to have p squared plus q squared all squared equal to 48 squared plus 64 squared. Okay, so I have p squared plus q squared all squared. Now this will give me 2,304 plus 4,096. 4,096. Okay, so once I add up this, so I'm going to get 6,000. I have 496 2304 00. That's 6,400. So that will give me 6,400. So I have p squared plus q squared all squared equals to 6,400. So I have to take the square roots of both sides. So I get p squared plus q squared equal to plus or minus 6,000 square root of 6,400. So I have p squared plus q squared all equal to plus or minus 80. But you see, p has to be always positive, or let's say p squared is always positive. Same thing with q squared is always positive. And so if that's the case, that means that p squared plus q squared will be greater than 0. Okay, so there is no way. So if these conditions are met, that means that p squared plus q squared will be equal to 80. Now, we can use the identity for p squared plus q squared. And what is that? We should note that, or recall that a squared plus b squared is equal to a plus b squared minus 2ab. Yes. So I'm going to use this. Therefore, this becomes, so this will become p squared. So that means that p squared plus q squared becomes p plus q rather, p plus q squared minus 2pq equal to 80. And so pq is already known as 32. pq is 32. Now if pq is 32, so I have p plus q squared minus 2 times 32 equal to 80. So I have p plus q squared minus 64 equal to 80. So I have p plus q squared equal to 80, and if this comes over, it becomes 64. Okay. So we have that p plus q all squared will be, once these two are added up, I think that's going to give us 144. And then of course we can get our p plus q to be plus or minus square root of 144. P plus q will give us plus or minus 12. Now, just as we already established here, p and q will always be greater than 0. Okay, so we have p greater than 0, q greater than 0. Therefore, p plus q will be greater than 0. Is that okay? So once that is established, we just come here and say p plus q will just be the positive value. So let's keep this. P plus q is 12. Can we find the value of p minus q? The answer is yes. We can go ahead and find the value of p minus q. So we know that p minus q will give us p plus q squared minus 4pq. Okay, we know that p minus q will give us p plus q squared minus 4pq. That is from algebraic identities. Okay, so once that is established, then we can say that p minus q will simply give us p minus q, then will give us p plus q is already 12 squared minus 4 times pq. Pq is 32. So we have p minus q equal to 144 minus this will give us 128. Yes, 4 times 2 is 8, 4 times 3 is 12, so that's 128. So p minus q will give us the difference between 144 and 128. That should be 16. That should be that should be 16. Okay, let me investigate that correctly. I think there is a mix-up somewhere here. Okay, so the mix-up, please, let's come back here. P minus q squared should give us this, not p minus q. So p minus q squared should give us this, okay? Please, I accept responsibility for that. So p minus q should give us this, and then we'll go ahead to say that this should be squared, this should be squared, and this should be squared. So from here we have 16, yes, p minus q, then will give us plus or minus 16, that's square root of 16, p minus q will give us plus or minus 4. As usual, p, because this is a difference, p will be greater than q, and that will be greater than 0, so that p minus q will be greater than 0. Of course, there's a difference here, so p minus q, okay, will always give us positive, and therefore, because of that, p has to be greater than q, and q also has to be greater than 0, and so the difference between them will be greater than 0, and so we go for the positive value, p minus q equal to 4. So now we have established p plus q, which is this, and p minus q, which is that. So now let's combine the two equations, okay? Let's combine this. So if we combine p plus q equal to 12 and p minus q equal to 4. So what's that going to give us? By the time we add up and solve simultaneously, first we add up. So once those are added up, once the two equations are added up, we're going to get 2p equal to, because this and this will simply cancel out each other, equals to 16, and so p will be equal to 16 over p will be equal to 16 over 2, so p will simply give us 8. So if p is equal to 8, we can easily find the value of q. So we know that p plus q equal to 12, and if p is 8, we have 8 plus q equal to 12, and then q will give us 12 minus 8, so q equal to 4. So we have p as 8 and q as 4. Okay, p is 8, q as 4. Now do not forget that we have represented p to be equal to 2 raised to power m, and q to be represented by 2 raised to power n. Okay, so if p represented by p raised to power m and q is represented by, or is it a now? I think it's a. Alright, so okay, so let's just have it that way. So we have now that let's go back and see. But p equal to 8 here, so you have 2 to the power of m equal to 8. So 2 to the power of m equal to 2 to the power of 3, and 2 to the power of m equal to, so if so that means the bases are equal, and therefore powers will be equal. The same way, 2 to the power of n equal to 4, 2 to the power of n equal to 2 to the power of 2, so bases are equal, therefore n will be equal to 2. Therefore, n is equal to 3, 2. So that's why we have it for the long version. Now let's look at the short version, or the short method. I'm going to go back to the original equations. That will give us, so let me start over from this end. So from the original equation, where we have 4 to the power of m minus 4 to the power of n, that's second method, which is the shorter method. So, equal to 48, and we have 2 to the power of m plus n equal to 32. So I'm going to start, let's call this equation 1 and this is equation 2. So I'm going to start from equation 2. From equation 2, we have 2 to the power of m plus n equal to 32. 2 to the power of m plus n. We know that 32 is 2 to the power of 5. Okay, so basis and basis, the basis on both sides will undo each other, so I have m plus n equal to 5. So what I'm going to do now is to say that from here I can get that m equals to 5 minus n. So I take this and substitute into equation 1. So from equation 1 is, from equation 1, since m will be equal to 5 minus n, so equation 1 becomes 4 to the power of 5 minus n minus 4 to the power of n equal to 48. Okay, so I have 4 to the power of 5 times 4 to the power of 4 to the power minus n minus 4 to the power of n equal to 48. So that I have 4 to the power of 5 all over 4 to the power of n. Okay, so minus 4 to the power of n equal to 48. So let a equal to 4 to the power of n. So that this equation now becomes 4 to the power of 5 all over a minus a equal to 48. So what we have here is now, if I multiply each term by a, so I have a times 4 to the power of 5 all over a minus a times a equal to a times 48. So this and this will go. We have 4 to the power of 5. I hope that's correct. Minus a squared equal to 48a. So this is becoming a quadratic. So we have, so I'm going to rewrite this to give me a squared plus 48a minus 4 to the power of 5 equal to 0. A squared plus 48a minus 4 to the power of 5 is like saying 16 multiplied by 64. What would that give us? 16, 64, 16. We have 4, 2, 38. We have 4, 6. So we have 4, 2, 10. 1024. So we have 1024 equal to 0. Of course, we know that 16 minus 64 minus 16 will give us 48. So this becomes a squared minus 16a plus 64a minus 1024 equal to 0. And so we have a squared. So if we are to group and factorize, we have a minus 16, a times a minus 16 plus, what is common here? We are going to have a common factor here, and that common factor will be, I think 4 brackets here, 4. So that 4 times, is it 4 or 3? 64 times 2. I think that would be 16 times 4. This is 4. Okay, I think that's correct. 16a. Sorry, 16a. I think that should be what's going to be common here. That would be, I think 64 should be the common factor. 64 bracket a minus 16, yeah, equal to 0. I'm almost getting confused right there. So we have a minus 16 times a plus 64 equal to 0. So we have a minus 16 equal to 0, or a plus 64 equal to 0. So I have a equal to 16, or a equal to minus 64. So, but we know that a equal to 4 to the power of n. A equal to 4 to the power of n. So we have a equal to 4 to the power of n. So we have 4 to the power of n equal to 16, or 4 to the power of n equal to minus 64. This cannot be 4 to the power of any number cannot be negative. It can't. So we have this to be rejected, and we'll stick with this. 4 to the power of n equal to 16. So 4 to the power of n equals to 4 to the power of 2. So by virtue of common base law, n will be 2. So if n is 2, and we already know that m plus n is 5, and n is 2, so m plus 2 will be equal to 5. Therefore, m will be equal to 5 minus 2. So m equal to 3. Therefore, m comma n will be equal to 3 comma 2. Okay, so there you have it, guys. The solution, both the long version and the short version, give the same result. So please, guys, watch, learn, share, subscribe, like, and then of course your beautiful comment in the comment section. I see you in my next video. Thank you very much.